Зустрічайте нашого наступного спікера Kostantinos Kourmousis. Він є solution архітектором в AWS. Також він є Generative AI Ambassador, який інтегрує Artificial Intelligence з хмарною архітектурою, і розширюючи можливості для надання передових та ефективних рішень взагалі. Сьогодні він з нами поділиться наступною темою, яка звучить як AWS IoT in the driver's seat – Transforming Automotive Data Gathering and Analysis. Хочу нагадати про слайду. Ми, звичайно, будемо проговорювати всі питання, і це буде, думаю, трошечки таке продовження теми про Automotive, як ми сьогодні вже і почали. Так? Greetings, Kostantinos. We are glad you have joined us today, and we are all ears to hear what you have got to share with us. Looking forward to your talk. The stage is yours.
Thank you, Dimitro. It's so nice to be here. Thank you for inviting me. I apologize that we have to switch in English for this session. I heard your introduction and I'm pretty sure that I understood some of the things you said about me. So, hello everyone, I'm Kostantinos Kourmousis, Kostas for short, I know that's easier. I'm a solutions architect focusing on CE territories, working in Amazon Web Services. My background I have a solid background in telematics and IoT, even in my previous roles and positions. And I chose this path of specialization within AWS as well. I'm also a generative AI ambassador, as I just heard you saying about me. I understand that you had another colleague, Alexei, who presented earlier. It was funny because we realized lately that we had some overlap, meaning that he would speak on the same industry focus, automotive. But I want to hope that we manage to separate our slides, our topics, our content, so that you will not get bored by seeing the same things over and over again. Give me a second to switch to my slides. So, right to it. As you know, over the last several years, the impact of Internet of Things has continued to grow. According to IDC, there will be more than 40 billion connected devices by the end of 2023. There are some industries that are seeing lots of growth. One of them is manufacturing, where 51% of manufacturers are using IoT already today, according to IDC again. And also another big area of growth is connected vehicles. McKinsey predicts that by 2030, 95% of vehicles will be an IoT device on wheels. So we are talking about vehicles connected to the internet, sharing information. We're going to be focusing for my session as well on this specific industry, automotive. We're going to have a different point of view, hopefully. But first, I want to give the opportunity to all of you to take a step back and start realizing, why are we doing this? Why are we having this conversation? What is the problem we are trying to solve? So in the center of everything is information, intelligence, and the outcomes of it. In order for us and you to gather as much as intelligence and information and have the best outcomes, we have envisioned a cycle in AWS, the IoT cycle. It consists of services that are split into three distinct categories. First, bottom right, you have device software, and we provide help to customers to connect their devices to the cloud. Help with Greengrass, like Alexei talked about, with free RTOS and other tools to directly connect to the cloud. Aside from the device software part, we also have connectivity. Connectivity focuses on what you can securely handle when it comes to your fleet and devices. So services like IoT Core, device management, device defender, services that will help you connect your device to the cloud at scale and keep them healthy and secure. Lastly, we have analytics services. With analytics services like IoT Analytics, IoT Events, and Fleetwise, which will be the main focus of today's presentation. However, I want you to have a broader view of the services offered and what is the benefit of going with a service or a solution, like I want to call it, of Fleetwise. In order to do that, we're going to have to see the AWS for IoT stack. Apologies, my presentation is lagging. Okay, here we go. Here it is, the AWS IoT stack. So we have built everything on top of our own cloud services. And when we're referring to cloud service, we're referring to the foundation of AWS Cloud as we know it, when it comes to storage, when it comes to compute, databases, machine learning. And you can see we have designed and built some services on top of that. Some are purpose-built IoT services, like the one I mentioned briefly, FreeRTOS, Greengrass, IoT Core. Some are partner solutions going to the top right now to help us build smart buildings, smart home solutions, or digital twins. And I wanted to focus on the middle layer of the stack to the industry. We have some services that I want to refer to as solutions more than services because they are something like a black box. I mean, they come ready to help our customers jumpstart and get as much value as they can by using these services. This is the key takeaway from this slide, and we're going to focus on this differentiator of AWS IoT Fleetwise soon. Now, as I said, we're going to be focusing on the automotive industry. This industry has its own challenges in collecting massive amounts of data, the cost and the complexity that comes with that. Another challenge is how can they maintain agility, and by they I mean our customers. So a customer, an OEM, an automotive manufacturer that is going to implement IoT into their solution, their vehicles, they cannot sacrifice their company's agility and speed of innovation by integrating new workloads like IoT. And this is a true challenge. I have seen it personally because once you get your engineers to start validating data, debugging stuff, you really need to invest on something managed that is there to help you with the bureaucracy of such tasks. So this industry has its own challenges, but we have the tools to tackle them at multiple layers. And by layers, I mean an architectural layer of what we call a connected vehicle. So starting from the bottom, you see you have your device layer, your actual hardware, the operating system, anything running on the device. And by device, I mean a compute unit running into the vehicle, or maybe some functions or algorithms running into the actual TCU of the vehicle. And on top of that, we have the connectivity layer. Alexei spoke about that quite a lot, I believe. So how we get connected to the cloud. And once we're connected, then we start facing the true challenges. We need to abstract as much of complexity as we can and handle multiple fleets and models of vehicles in the same way. You can abstract that in two ways. So software-wise, by containerization, pipelines, etc. And what we're going to be focusing today, data abstraction layer. And this is quite a challenge in automotive industry. On top of that, we have the top layers that are operations and applications layer, pretty much how you can observe your the bottom layers, how you can monitor your bottom layers, and how you build applications for your end users to experience the results and of your solutions. So there are some regions. Customers build connected platform with cloud and AWS. You can see most of them. I would say data efficiency is a great one, and scalability, because we are talking about millions of vehicles that we want to keep connected. If you were to do this with on-premises infrastructure, there could be quite some challenges when hitting those desired high availability and durability ratings. And of course, if you are a client that operates, or if you are building something for a client that operates in multiple regions, then you're definitely going to benefit from the ability that AWS gives you to go global in minutes. And by doing so, we have some use cases as examples that our customers have realized, but by using different services actually. So with IoT Core, which Oleg focused on, our customers are being able to build mobile applications for their remote vehicles to do some pretty custom-made actions to gather insights or interact with the devices, like remotely started vehicles or so. With Fleetwise, we are going to be focusing today. Our customers are able to collect vehicles diagnostics and alerts in a very interesting way. And there is also live vehicle video. We're not going to be focusing on that today. We have Amazon Kinesis video streams. There is also vision data coming into Fleetwise as well. This was announced lately in reInvent. But let's move on for now. Now, I won't be diving into this one. Don't be intimidated by that. This is just an architecture diagram I want to show you to see that there are multiple ways to reach the target. So in order to build mobile and web applications, one could just connect a vehicle with AWS IoT Core, store everything in a time stream or in S3, and then for that, or even into a data lake, and then from that, draw analytics to Grafana or machine learning or QuickSight, SageMaker for machine learning. But there are also other approaches. For example, something more complex here, where in this example of a reference architecture, there are more than one tools, each one for the right job. I want you to focus on the on the left side, we have the connected car, and I want you to focus on the next layer where we have the services that we see that we utilize to connect our vehicle to the cloud. In this case, Fleetwise, IoT Core, device management. So we have many tools to do many different jobs. What should we choose? What should we use? Why are there so many? So this is another example where we utilize its service for the right job, or the right for this use case at least. To connect it, maybe we can use IoT Core. Also to control the vehicle. For fleet operations, we can use device management and Fleet Hub. For insights, of course, that's pretty much basic. I mean, that's going to fit everywhere, QuickSight and Grafana. But for that abstraction layer, we see here that IoT Fleetwise for this reference architecture has been the service of choice. And let's see why. Because with AWS IoT Fleetwise, it will be easier for you and more cost-effective to transform and collect data from millions of vehicles to the cloud in near real time. That is a basic description. So it is a service or a solution, as I want to present it, even though it's not officially a solution, that allows our customers to collect insights near real time from millions of vehicles in a very interesting way. And we were talking about vehicles, as I mentioned earlier. I mentioned that by 2030, 95% of them will be connected to IoT. We have vehicles with even more and more and more richer sensors. And this is actually big data. And it is hard to handle this. And this is one of the main challenges that our customers realize when it comes to handling information from the vehicles. You see, there are two main issues. The first one is data fragmentation. And here is the first key takeaway when we are focusing on Fleetwise. So you have to understand that different manufacturers have different protocols for their data or data formats for the information that is going to be transmitted from the vehicle. And let me give you an example here. For example, let's say manufacturer A has a model 1, and for that model, the vehicle speed is going to be transmitted in message 100, and it's going to be measured in kilometers per hour. But another manufacturer, or even the same manufacturer in some cases, but another manufacturer for another model, they will have vehicle speed transmitted in message 200, and it's going to be meters per second. So we have this fragmentation. This, if we want to manage a fleet of vehicles, it's too hard. We have to keep a single point of truth somewhere, but where is that somewhere? That's one issue. That's one major challenge. And another one is data tsunami, as we call it. So with all those sensors and even more and more of them coming into integrating into the vehicles nowadays, we're getting a very, very large amount of data to process, and pretty almost usually, I will say usually, more than we should. We don't always need sensors from cameras, and we don't always need sensors for everything, not only when it makes sense for us. And so Fleetwise addresses these two standard and major challenges by providing a standardized way to handle vehicle data. I will show you how in a while. For now, just imagine that Fleetwise is the answer to the problem: how can I have a single point of truth to address my multiple models of data coming from different vehicle manufacturers? And second key feature of IoT Fleetwise is that it allows us to intelligently collect data. So we are able to operate at the edge, and by that I mean on the vehicle in real time, and make a decision. Do I want to publish this information to the cloud? Do I want to forward this information or not? So this allows many customers to benefit from IoT Fleetwise. Automakers, OEMs, they're tier 1 suppliers with hardware for the actual manufacturing process. Telematic solutions providers, that could be one field that could interest your audience, you that are listening right now. Probably possibly working in a telematic solution provider, or other auto providers like data loggers or rideshare or something like that. And this allows for many use cases. We can actually monitor, for example, electronic vehicle batteries, monitor their health and improve their age. We can train machine learning models for autonomous vehicles, like the ones we're already seeing working, roaming the streets, I would say. Quickly identify some issues and potential warranty claims. And in general, analyze driver safety, uptime of the vehicle, very useful insights for any of the personas that I shared in the previous slides. So how does this work? So we talk about the solution, we talk about the black box. It's something that comes to help us. It is different from IoT Core. I will state this at this point. So again, if you remember that complex architecture diagrams, I told you that you can do many things with many tools. You could do this with IoT Core if you wanted to. You could connect your vehicle to IoT Core. You could use Rules Engine to push every data into your data lake and handle it then with a Lambda that knows the data formats of model vehicles. But it's too much work for someone to do, and without good reason for that manual work in many cases. That's why we have built AWS IoT Fleetwise? Because for most cases, it's like most managed service from AWS. It offloads administrative overheads from our customers. Now, in this case, as a first step, we model our vehicle and its sensors, and we will see in detail how this works. So that single point of truth I've been talking about earlier, we do it in Fleetwise. We say this is a single point of truth. This is what vehicle speed is for me. I will call it Costa speed, or obviously vehicle speed, but I will have one signal called vehicle speed, and we are not going to focus to the differences per automotive manufacturer at this point. Then we connect to the vehicles by using a very small standalone software called IoT Fleetwise Edge Agent. So this is a small software running on the vehicle. It could be running on a discrete compute unit. It could be running on the actual TCU. Some manufacturers want to embed this in their own hardware. It is portable. You can do that. And we, at some point, that I will tell you later not to confuse you, we are somehow know how to expect vehicle speed from model A, how to expect vehicle speed from model B, and bring it all together. So we select information. We select information based on what we want. So we create something called campaigns. We will see about that. And we run those campaigns, and we collect our information using our Fleetwise Edge agent. And we get that information back to us, and we can feed it into analytic applications. So in the very high overview, we model the information we have for every vehicle we want. Per model manufacturer, we kind of declare how to translate that information. We have that agent running on our vehicles. We declare some campaigns saying, I want the vehicle speed from our vehicles, and we collect that information automatically. And so let's see some examples of what this campaign is. So we can say, for example, I want to examine a specific vehicle, and I want to run a campaign for a single vehicle. Give me everything for that single vehicle. All the signals I have, all the information I have declared in my model, I want it for that vehicle. Or I want to check only battery health. So maybe give me every battery-related information for all the electronic vehicles in North America. You can go like that. You can transform business requirements into actual campaigns, and this will affect the vehicles that will respond with the information. Or you can even target some the vehicles with some decrease of speed to possibly identify some accidents or something like that. So again, we have some business personas, some analytics personas in the cloud that are designing and creating campaigns. Spreading the campaigns to the vehicles is automated. All the vehicles will get these campaigns, and each vehicle will realize if they are subject to this campaign, if they need to send information. And that's how we evade the tsunami. So each vehicle knows, I don't want to send my battery health information because I wasn't asked to. I'm not in North America. I'm not an electronic vehicle. And this is one differentiator you get with Fleetwise out of the box. So let's see some example campaigns for electronic vehicle battery health. So again, in the model on the left side, we have declared some attributes that are common to all of our vehicles. We have declared some signals like voltage, state of charge, duration of charge, discharge temperature of the battery. And we want to create some campaigns. For example, every 30 seconds, give me a voltage and current. Or if a battery has temperature smaller than 30, lower than 30 degrees or larger than 90, I want this information that it's going to be extra. So by this, we're gathering valuable insights like failure prediction. We are able to predict failure or performance degradation. or range estimation. This is similar to I forgot predictive maintenance. Yeah, it's similar to predictive maintenance, if you may. It helps with it may help with that. So let's go a bit deeper now, and let's see what are the data types that we use to model a vehicle. Because I told you I will show you how do we get there. So it all starts with a signal catalog. This is the higher level of information. So it's just a list of strings actually that you say, I want to have tire pressure, environmental pressure, temperature, or even battery level. It's just that. Uh, we have something called vehicle models or model manifest, which is specific for its vehicle type. So you say that this vehicle, in this case Volkswagen Golf, does not have all the signals from my catalog. Does only have that only has tire pressure and environmental temperature. You specify a subnet for this vehicle model. And then for this vehicle model, you create instances of your actual vehicles. So you're going to have 1 million vehicles. You're going to declare instances of 1 million vehicles in your Fleetwise service. That is paired is an instance of the vehicle model for Volkswagen Golf, if you have 1 million Volkswagen Golfs, representing the actual physical vehicle. Then, here's where the magic comes. So you have here to have the decoder manifest. What the decoder manifest does is taking care of that data discrepancy that we talked about. So Volkswagen Golf has the speed in different signals and messages actually than Toyota Yaris. So you say that this vehicle has attached a decoder manifest, and for this vehicle, if you want tire pressure, you're going to find it in the message ID example, starting on that bit with length of that many bits. So this is being pushed actually down to the vehicle. When the vehicle operates and it runs the agent inside of it, it gets the decoder manifest, so it can actually translate this information and to translate it to what it makes sense for your signal catalog. You're not going to get hexadecimal values. You're not going to get bits. And you're going to get what it makes sense to your signal catalog, to your vehicle model. And you're going to get it when you create a campaign. So you create a campaign that refers to the signal catalog. You say, using this signal catalog, I want to target this fleet of vehicles. Spoiler, I used fleet, so let's see fleets as well. So you can create something like a container multiple vehicles, or you can target specific vehicles, and you run the campaign on those. So you can say, I run the campaign of this fleet or this specific vehicles. And that's how it pretty much works. One thing that it is not displayed here, and I want to mention, is that inside the vehicle, where the edge agent runs, so decoder manifest is not enough to decode information. How things work inside the vehicle is like you have a bus. One bus, usually, it's the most common communication bus for information inside the vehicle. So it's what we call CAN bus, you may have heard. So it's a single bus where every sensor publishes information about the measurements they get. So we constantly, inside the vehicle, we constantly have information being published for different sensors on this CAN bus. But this is hexadecimal, this is raw data. And decoder manifest is not enough to decode this. What you need is what is called a DBC file. So this is actually the dictionary. Its manufacturer for its vehicle model has a separate, a proprietary, actually, in many cases you have to buy additional information of the free that you get openly. DBC file, where there is declared that, message ID 100 has these signals inside it: tire pressure, environment, and even battery. So you need that in order to do that. But it's not displayed here because it's kind of assumed, since everyone working in the automotive industry kind of knows that if they want to decode information, even without the cloud, even if you want to plug something in there and work with the CAN bus, you need that DBC file to decode the signals that are being transmitted in the CAN bus. But other than that, everything is here in the workflow of IoT Fleetwise. And let's see that workflow not in action, in a diagram. So on the left side, we have our vehicle running our vehicle Fleetwise Edge agent. We have the ECU in the bottom, publishing information in vehicle networks such as CAN bus that I mentioned earlier. And Fleetwise Edge agent is constantly reading and monitoring this CAN bus and decrypting information there. So on the right side, we have the cloud. We have on the top different personas, vehicle engineer, data engineers, and we have the cloud with IoT Fleetwise on the cloud, not at the edge. So the actual service. And how the flow goes here is that you model, as we said, our vehicle sensors in the signal catalog. You define the rules in the decoder manifest. So that's being done on the cloud. Step number one, this is done by vehicle engineers. So step number two, I switched those. They usually are reversed with step number 2 and 3, but I wanted to switch them for now because I like to say that first. So step number 2, you define a campaign for data collection. So what data, what information you want to collect, and you apply that campaign to a fleet. And step number 3, you collect that information because Fleetwise Edge agent receives that campaign, runs the collection, ingests data, and sends them back to the cloud. And from that point on, IoT Fleetwise stores that information, those data, into time stream database. So this is a time stream data storage, and you can also you can use that information stored there with Grafana, with any other system that you want to use to visualize your data. But the essence here is that this is very high level. This is very managed, so we don't actually bother with many details, and we have something to guide us when and how to pay attention to what is really important for that process, when and how to model our information to have a single point of truth. And as long as we have our DBC files on the vehicles, as long as we have our decoders manifest, Fleetwise agent will handle the rest. Will monitor the bus, will get new campaigns, will reply back the data collected based on that campaigns. And again, you can plug in Grafana, for example, or even TwinMaker to use to visualize this information, and you can end up with something like that, which is an actual dashboard that we built for a workshop that we run now in the reInvent that just happened, that is intended to monitor electronic vehicles for battery health and spot vehicles that are malfunctioning. This is something that, again, it is a managed service trying to make the life of our customers easier. If you want it, you could do that with IoT Core. If you want more control, if you want something more custom, maybe your information not being stored in time stream. But for many automotive manufacturers, this solution is the right, this service is the right tool for them to offload administrative overhead for this kind of workflows. So how can developers connect to IoT Fleetwise and partners? So pretty much how to use Edge agent. We have both. Developers can use both aftermarket and embedded devices. Edge agent is portable. You can port it to target hardware of choice. It runs on. It's very small. It's like 5 megabytes. It runs on Linux-based platforms. It's open source and it is available on GitHub. And you can find, if you want supporting information, you cannot click the screen right now, but reach out to me. I will have my information, my contact information later for you to contact me via LinkedIn if you need more resources on that, if you are interested in running the workshop or something. So I hope we're on time. I didn't have visibility on the counter and timer, but we reached the Q&A session. And I would be more than happy to hear any questions you might have for me at this point.
Yeah, definitely. Thanks, Kostas. That was a lovely presentation, and we're definitely on time, so we've got time to get a question or two. So yeah, perfect. So yeah, I mean, one of the questions that we've got is indeed about the entire fleet service, right? So, and it goes as follows. So it's not a direct one, but an overall one. So imagine we as implementers, we decide to build a complete fleet tracking solution with AWS, right? So the question that there is there an estimate of how much work has already been created or implemented by AWS, so to speak? So what in terms of, well, its percentage, right, of the development, it is going to save us to use the service which you are describing? As I said, it's a big one.
Yeah. So I'm going to go with the cliche here. As always, it depends. It depends on the use case. It depends on many things. But what I want to highlight here is that for those that watched Olex's presentation earlier, you saw that we didn't speak about security. This is being handled by Fleetwise agent. We didn't speak about rules. This is being handled by the campaigns that you're going to run and how it's going to be run. So I cannot translate it to actual percentage, but many a great percentage. I know that many customers going with a raw approach with IoT Core is to define a security lifecycle policy, how to manage their certificates and stuff like that. So that's one benefit definitely to consider. And then you are also going to have to take into consideration how is it going to be this way to get to actual useful information. So I could say that you are maybe you can cut corners when it comes to ETL, extract, transform, and load. So if you go with IT core, you may end up getting more data that you need in some cases, even though you could handle some of those in rules engine, and you would have to perform some transformations, because of what the discrepancy I mentioned between different models, different manufacturers. You would have to do that. So you will have to transform meters per second to kilometers per hour. You are adding more chains to the link. Again, there is not black and white. There is no true good or bad here. It's per use case. One benefit with Fleetwise is time to market. So for some customers that want to have a great time, a very small time to market and innovate faster, this is a good option for them. I will not say it's perfect. I know it has some flaws. I personally would love to see it being able to direct information, not to a timestream database through IoT Core, so I can do my stuff when I want to. We're not there yet. But again, for some customers looking for something to jumpstart, as I said, it's a great choice.
So indeed, you see it, well, as a tool to kick off faster, and of course, I'm able to build up upon, right?
It doesn't mean that you have to replace it in the long term. Maybe it will be enough for your use case, depending on the use case, depending on the actual needs.
Yeah, definitely. And of course, I mean, at the moment we don't have any specific use case. We're just discussing this in general, right? I mean, once you are facing a real problem you need to solve, then of course, I mean, there are going to be some challenges and some pitfalls. Well, speaking of, are there any pitfalls that a typical implementation would be susceptible for?
Can you rephrase that to make sure I
Yeah,
understood
definitely.
correctly? So
So
the downsides, maybe? That's why.
probably the downside, but in this case, are there any, I want to say simple failures, right, that some people can expect when they start and work with the tooling, right? Is there anything that you see, right? So 50% of
Okay.
people when they start working, they do this wrong, but they needed to focus on that or anything like that. If you've got anything like this.
I would say they need to focus on the ability they have to decode the information they need, because they may have a great idea, they may have something very good in there, but as I said, some DBC files are proprietary. That means you need to buy them. So that's valid also without Fleetwise if you go with anyway. But that's a tip I want to share. So make sure that for your plan, for your business plan, for anything, you can actually get the information you're basing your project at, because this is something that is not always guaranteed for all models. I've seen projects targeting garbage trucks, and not being able to collect speed information from half of them because the manufacturer did not give that information unless paid dearly for that. I don't think I don't remember if it was actually speed, but that's an example.
Clear. That makes sense. Thank you. And one more question that we have got here is, well, obviously a lot of things which you sort of described and which you focused your presentation on is, partially at least, electric vehicles, right? I mean, some of the things with regards to charge of the battery, whether it is your accumulator, your battery that you use for the headlights, whatever, or for running your vehicle in particular. Do you see that there's also sort of an implementation possibility for older cars, right? Some sort of add-on that, for instance, you are a taxi company and whatnot that utilizes the services and modifies their cars in a way using some people call it a sidecar, right? But a modification to their vehicle that would be communicating and or retrofitting the older cars to be able to communicate with AWS services in this case.
Yes, that's a great example. I don't have a use case ready. I would be more than happy to find one. I'm pretty sure someone out there did this already. But yeah, overall, I want to say that the basic information that most users would need is not logged. So usually what we've seen is that some manufacturers log some specific signals and the rest are public for everyone. So I may have been too intimidating when highlighting that. Make sure you have access to the information you need. But for basic information needed, this comes easier if you have like an onboard unit, so a dedicated compute unit, possibly with an external GPS sensor or something like that. Then you are not so relying too much on the actual manufacturer. So even for difficult situations, there are workarounds there, and this is a service that this is targeted to both users and developers that want to have some applications like the great example you just said, also to manufacturers. So you have to keep in mind that there are some customers there, probably 100 of them around the world, that do not care about DBC files being proprietary and stuff like that because they own them. But for the rest of them, you don't always have to rely on this DBC file to decode everything, because if you're not an automotive manufacturer, you're just a developer, you're most probably going to be running this agent and the logic behind it on an external compute unit, or maybe something that has attached, again, as I said, a GPS sensor. So it's not a dead end always.
Yeah. So basically, I mean, again, just to, well, not to clarify, but to stipulate, right? So if I had a Raspberry Pi, I could probably try and, well, a toy car of sorts, right, and create a fleet of toy cars with Raspberry Pis that would be essential, integratable into the system, right? And I could have built that having no affiliation with car manufacturer whatsoever. I could
Yeah,
have
sure.
developed that on a completely custom hardware.
So yeah, that would require some workaround, since again, Fleetwise is a ready solution that is targeted to monitor CAN bus, as I said. So what you would have to do in such scenario would be to find a way to create your own DBC. This is something you can do actually. So you can create a virtual CAN bus inside the Raspberry Pi. You can have your own DBC. I declare that my GPS latitude is inside message 100. It is starting bit 1 to bit 12. And you would have
Right.
to create the function that will encode this and transmit it and publish it into the virtual CAN bus. But then it would work, because if you had set Fleetwise Edge Agent monitoring that bus, that virtual CAN interface, it would work. You would say, here is my decoded manifest, here is my DBC file, even though it's not an automotive one.
Yeah.
So that's a workaround. It's just, so DBC file is just a file of. I actually did this for the workshop. I saw the dashboard you saw earlier. So we were missing some signals that we wanted to have in there for a use case of the workshop, which was firmware version. Yeah, so we wanted a signal called firmware version, and I pretty much injected that. So I found an area in the DBC that I could use. I declared a message there. I told in my decoder manifest that these are the bits and bytes that I'm going to be sharing this string. It was a double representing the firmware version, and it worked. So you have definitely the room to play around there, even without proprietary DBC files, if you want to.
Thank you so much. Thanks so much for the answers.
My pleasure.
And of course for your topic. I mean, it actually was a really indeed a good collaboration / continuation with the Alexis topic, right? I mean, I don't think there was too much overlap, as you said, but yeah, it was
we tried.
definitely a package.
Yeah, Alexei picked it up. The overlap. If you didn't, you would be unpleasantly surprised by seeing some overlapping content. But I think we split that in a way that it kept the audience engaged. So if you want, please share this last slide that I have, if you're able to, which has my contact information for anyone that wants any additional guidance or any way I can help with. And it also helps. Are you able to see my screen sharing still?
I'm not sure if you can we share the screen right now?
Oh yeah, that's it. Can you still hear me?
Yeah,
that was
perfect.
enough
Yeah,
for someone.
the screen
That was enough for
yeah.
someone to take a screenshot. Yeah, that was enough.
Yeah, exactly. But anyways, I mean, everything is going to be in the recording, so people actually can scroll back.
Reach out to me in LinkedIn. Yeah. Also, there is a QR code there. We love your feedback always, so feel free to give me some feedback on this session. It's most welcome. Your sincere feedback, as I always say. It was a pleasure. I want to say that the level is very high. The bar is very high with your user group. Sorry, you are extremely well organized. Congratulations on that. And I will be spreading the word about the work you are doing there.
Thanks so much. The pleasure is all ours. Thanks so much just for joining us today. I mean, it was a pleasure having you.